For nearly a century, we thought we understood the beginning. A single explosion of creation, the Big Bang, that gave birth to everything we see. Time, space, matter, energy. The first atoms condensed into stars, stars into galaxies, and galaxies into the vast web of the cosmos. That was our story. That was our certainty. Until now. Because the James Webb Space Telescope has seen something it shouldn't have. Something that breaks every rule we thought the universe obeyed. Light from galaxies so ancient, so impossibly bright and massive, that they seem to exist before the universe was even supposed to begin. If this discovery holds true, then the Big Bang wasn't the beginning. It was just one chapter in a much older story. For decades, we've drawn a line at the Big Bang and called everything before it nothing. But what if that nothing wasn't empty at all? What if the cosmos had a history before time itself began to tick? The James Webb Telescope is showing us light that has traveled for over 13 billion years. Ancient photons carrying messages from the dawn of everything. And yet, some of those messages don't fit the timeline. They whisper of galaxies that shouldn't exist yet, stars that appear too old, structures too evolved, chemistry too complex for the infant universe we thought we knew. When Webb turned its golden mirrors toward the deep field, a patch of sky smaller than a grain of sand held at arm's length, it expected to see faint traces of the first galaxies forming. Instead, it found hundreds. Fully formed, shining, structured. Galaxies that shouldn't have had enough time to exist. The universe, it seems, was already busy before it was supposed to begin. If these findings are real, and all evidence suggests they are, then our most trusted cosmological model, the very timeline of existence itself, may need to be rewritten from the ground up. Not because the Big Bang didn't happen, but because it might not have been the start. For 70 years, we've studied the universe under a single assumption, that time has a beginning, that everything, from the first atoms to us, has unfolded in a straight line from that cosmic flash. But what if that line bends? What if there was something before, something beyond? A hidden era whose light is only now reaching us. If you want to see how scientists are rewriting the history of the cosmos, hit that like button and subscribe, because this is the story of how the universe may have existed before the Big Bang. Prepare yourselves. We begin. To understand what Webb found, we have to understand what Webb is. Not just a telescope, a time machine made of gold and silence. Orbiting 1 million miles from Earth at the L2 point, it stares into the cosmic abyss where light travels endlessly through the void. Its 18 golden mirrors collect that ancient light. Infrared radiation stretched thin by billions of years of cosmic expansion, and focus it into an image so sensitive it can see the faint heat of galaxies born before the first stars died. Where other telescopes see light, Webb sees time. Every photon it captures is a message from the past, a moment that left its source billions of years ago and has been racing across the universe ever since. When we look at a nearby star, we see it as it was years ago. When we look at a distant galaxy, we see it as it was billions of years ago. Webb's vision extends almost to the edge of time itself, the first flicker of starlight after the universe cooled from chaos. That's what scientists expected to see, the dim glow of newly forming galaxies, small, primitive, chaotic. Instead, Webb saw something that should have been impossible. Within its first deep field, a tiny fraction of sky that would look empty to human eyes, Webb detected galaxies so bright, so organized, that they defied all known models of cosmic evolution. Some appeared to be 10 times more massive than expected for their age, already containing billions of stars, already forming structure, already old. It was as if Webb had looked back to the beginning and found something already there. Astronomers double-checked their instruments, recalibrated their data, ran simulations again and again. The results did not change. The light was real. The redshifts confirmed it. These galaxies existed when the universe was barely 200 million years old. just 1% of its current age, yet they looked mature, evolved, ancient. That single observation cracked open the door to a deeper mystery, because according to everything we thought we knew, there should not have been enough time for gravity to gather gas, ignite stars, and build galaxies so large. The equations said it was impossible, but the light said otherwise. It wasn't just one galaxy either. Webb kept finding them, again and again, scattered across the early universe like sparks from a hidden fire. Each one a contradiction. Each one an echo of something older than time itself. Scientists began to ask a question they had never dared to ask before. What if the Big Bang wasn't the beginning of everything, but the end of something else? To understand how that could be possible, we need to revisit the moment we call the Big Bang. For generations, we've imagined it as an explosion, a single burst that created space, time, and matter out of nothing. But that image, while poetic, has always been misleading. There was no center, no detonation, no blast spreading into empty space. There was no space yet. The Big Bang wasn't an explosion in the universe. It was an explosion of the universe. Space itself expanded, stretching everything within it, pulling ancient light apart until it cooled into the cosmos we know today. And that expansion never stopped. Even now, galaxies race away from one another, carried by the stretching fabric of reality itself. The further something is, the faster it recedes. That's why Webb's infrared eyes are so powerful. They can see that ancient light stretched to near invisibility by 13 billion years of expansion. But here's where the mystery deepens. When cosmologists simulate the early universe, their equations begin with near-perfect simplicity. A hot, dense, uniform sea of energy gradually cooling and clumping under gravity. From that, galaxies should form slowly over hundreds of millions of years. Tiny fluctuations in density grow into stars, stars into clusters, clusters into galaxies. It should take time, a lot of time. Yet Webb's data shows galaxies that were already large and luminous when the universe was barely out of infancy. That shouldn't happen, unless something existed before the Big Bang to set the stage. Maybe the Big Bang wasn't the birth of everything. Maybe it was a transition, a transformation from a previous state the universe once occupied, a rebirth rather than a beginning. Some physicists have been exploring this possibility for years, quietly, on the edges of accepted science. They propose that before our expanding universe, there was another, one that collapsed inward under its own gravity, compressing everything into a singular, unimaginably dense state. And when that universe reached its breaking point, instead of ending, it bounced. That bounce, that rebound from a previous cosmic cycle, would look to us like a Big Bang, but in truth, it would only be one frame in an infinite loop. Universes expanding, collapsing, and expanding again, forever. It's called the Big Bounce. And if Webb's discoveries are real, it might not be just a theory anymore. Other scientists suggest something even stranger, that what we call the Big Bang wasn't the start of time, but the start of our region of the universe, a bubble expanding within a much larger, timeless multiverse. In that picture, countless other bangs could be happening right now, birthing universes with their own physics, their own stars, their own stories. Webb might be giving us the first observational hint that something like this is true, because the light it sees doesn't fit inside the boundaries of our model. It leaks through, like an echo from a time before time began. If Webb is truly glimpsing something older than the Big Bang, then the question becomes, what exactly is it seeing? For most of the last century, astronomers believed there was a hard limit to how far we could see, a cosmic wall of fog known as the cosmic microwave background, or CMB. It's the afterglow of the Big Bang itself, the moment when the universe cooled enough for light to travel freely. Before that, everything was so dense and hot that photons couldn't escape. The universe was opaque, a blinding plasma of particles and radiation. No telescope, not even Webb, can see through that barrier directly. But what Webb can do is follow the trail of light that's been bent, stretched, and scattered around it. Echoes of structure that formed even as that cosmic fog began to lift. It can observe the fingerprints of events that happened before the universe became transparent. Tiny irregularities in that first light, ripples in temperature and density, may hold the memory of what came before. And those ripples don't look random. Some of them carry patterns too large, too coherent, to be explained by simple quantum fluctuations. A few cosmologists think those patterns might be scars, faint imprints from a universe that existed before ours began to expand. Imagine the Big Bang not as a beginning, but as a collision, a point where two cosmic surfaces brushed against each other in a higher dimension. The impact released unimaginable energy, inflating our universe outward, leaving behind faint distortions, like waves radiating from a stone dropped into water. Those waves could still be visible in the background glow of the cosmos, and Webb's instruments are sensitive enough to detect the galaxies that formed along their edges. Some of the galaxies Webb has found, the ones that seem too massive, too evolved, too early, could be forming in the gravitational traces left by that older universe. In other words, they might not be anomalies at all. They could be the first visible fossils of a deeper cosmic ancestry. Every new deep field image Webb sends back seems to add another piece to the puzzle. And the deeper it looks, the stranger the story becomes. It's as if the light itself is telling us, the universe remembers more than we thought. The challenge now isn't just to explain what Webb is seeing, it's to decide how far back we're willing to follow it. Because if these signals truly come from a time before the Big Bang, then we may be standing on the edge of the greatest discovery in human history. Proof that the cosmos existed long before the moment we call creation. But not everyone agrees with this interpretation. In fact, the moment Webb's data was released, the world of cosmology split in two. On one side are those who say the telescope has shattered our understanding of the early universe, that these galaxies really are older, larger, and more evolved than they should be. On the other are those who argue that the data doesn't rewrite the laws of physics at all, only our understanding of how to read them. Some scientists believe the problem lies not in the universe, but in our measurements. They suggest that Webb's infrared sensors might be capturing light that appears more redshifted than it really is, making galaxies look older and farther away than they are. A few microns of misinterpretation could make a difference of hundreds of millions of years. Others argue that what Webb is seeing isn't truly impossible, just unexpected. Perhaps the first stars, known as population 3 stars, formed faster than we thought, fusing hydrogen and helium into heavier elements at breakneck speed. Maybe dark matter, the invisible scaffolding of the cosmos, clumped more quickly, pulling gas together to form galaxies earlier than our models predict. If that's true, then Webb hasn't broken cosmology, it's refined it. But even the most cautious scientists admit that something about these galaxies doesn't fit neatly into our current picture. Their masses are too large, their brightness too intense, their structure too organized for the time they had to form. Every new observation forces theorists back to their equations, searching for parameters that can make the numbers work. And the more they tweak, the clearer one truth becomes. The universe may be more complex than our best models can describe. This tension between theory and observation is not a failure of science. It's how science grows. Every revolution in understanding begins the same way, with data that refuses to behave. In the early 1900s, galaxies themselves were once considered impossible, until Edwin Hubble proved the Milky Way wasn't alone. Later, the discovery of cosmic expansion rewrote our view of time and space. Now, the James Webb Telescope may be leading us toward another transformation just as profound, and it's forcing us to confront a question that lies at the heart of all cosmology. Do we truly understand what time is? Because if Webb's galaxies existed before the Big Bang, then maybe before doesn't mean what we think it does. Time is the most familiar thing in the universe, and yet it may be the least understood. We live inside its flow, bound to its current, watching moments pass like stars across the night sky. But what if time itself had no beginning? What if it's not a river that starts somewhere, but an ocean, endless in every direction? Our current model of the universe assumes time began with the Big Bang. Everything, matter, space, even causality, emerged from that first instant. Before it, the equations stop working. They reach a singularity, a point where our understanding collapses. But to many physicists, that singularity isn't the beginning of time. It's a sign that our equations are incomplete. Something deeper, something beyond our current physics, is waiting to be discovered. One idea comes from loop quantum gravity, a theory that tries to merge general relativity with quantum mechanics. In this view, space and time are made of tiny, discrete loops, an invisible fabric of geometry itself. As the universe contracts under gravity, these loops resist compression. They reach a limit and then rebound. The result is a cosmic bounce. One universe collapsing gives birth to another expanding. In that cycle, there is no true beginning, only endless renewal. Another idea, proposed by physicist Roger Penrose, is called conformal cyclic cosmology. It suggests that the universe repeats in infinite aeons. Each aeon begins with what we perceive as a Big Bang and ends in a vast, cold, empty expanse, only for its stretched, dying fabric to morph into the seed of the next universe. In Penrose's vision, the death of one cosmos becomes the birth of another. Eternity is not a straight line. It's a loop, endlessly folding in on itself. Then there's the idea of eternal inflation, a model where our universe is just one bubble in an ever-expanding multiverse. New universes form constantly, budding off from quantum fluctuations in a larger cosmic sea. Each bubble has its own physical laws, its own constants, its own history. Our Big Bang, in that view, wasn't the beginning of everything, just the beginning of our bubble. And beyond it, there could be countless others, forever forming, colliding, and fading in an infinite cosmic foam. To many scientists, these ideas are still speculation, elegant mathematics without proof. But to others, Webb's findings may be the first observational hints that one of them could be true. Because if galaxies existed before the time our models allow, then something must have preceded our universe's beginning, a hidden past, encoded in the light Webb is only now revealing. Perhaps time, like space, curves back on itself. Perhaps beginnings and endings are illusions born of perspective. And perhaps the question isn't when the universe began, but why it keeps beginning at all. While theorists debate what time really is, Webb keeps sending back evidence that time itself might not behave the way we expect. Among its most startling discoveries are black holes that should not exist, ancient monsters sitting at the centers of early galaxies, only a few 100 million years after the supposed beginning of the universe. According to standard cosmology, there simply wasn't enough time for black holes this massive to form. Even if the first stars collapsed into black holes almost immediately, it would take billions of years for them to grow as large as the ones Webb is now observing. And yet, there they are, fully grown, ancient, active, bending space itself with their gravity. These black holes shouldn't just exist. They shouldn't even be possible. To form so quickly, they would need to start out enormous, perhaps hundreds of thousands of times the mass of our sun from the very beginning. That defies everything we know about how matter collapses, cools, and accretes. Some scientists now suspect these could be primordial black holes, ancient objects formed not from stars, but from direct fluctuations in the fabric of the early universe itself, remnants of conditions that might predate the Big Bang. If that's true, Webb may not just be seeing galaxies forming. It might be witnessing the fossils of physics that existed before our universe began expanding. And it's not just the black holes that raise questions. Webb's spectroscopic data, the chemical signatures of these galaxies, show elements like carbon, oxygen, and even iron appearing much earlier than they should. That means the first stars, the so-called population 3 stars, must have lived fast and died violently, seeding the cosmos with heavy elements far sooner than our models predict. Stars formed, burned, and exploded on cosmic timescales that should have been impossible. The early universe, once imagined as quiet and simple, looks instead like a place of furious activity, galaxies colliding, stars detonating, black holes merging, creation and destruction happening almost simultaneously. The more Webb looks, the less it finds a tidy timeline, and the more it reveals a cosmos already in motion, already ancient in its infancy. These discoveries blur the line between the beginning and whatever came before. If massive black holes and complex elements were already there, then perhaps our universe inherited more than just energy from a previous era. Perhaps it inherited structure, a kind of cosmic memory written into its very first light. It's becoming clear that the early universe was not a blank canvas waiting to be painted. It was already a masterpiece in progress, and Webb is showing us the brushstrokes left by an artist we've only just begun to recognize. Every image Webb sends back forces scientists to redraw the first pages of the universe's history. The early cosmos, once thought to be quiet and slow, now looks alive, crowded, restless, impossibly organized. And to explain that order, astronomers have begun to look at the invisible, the dark matter that shapes everything we see. In our standard model, dark matter forms the cosmic scaffolding, vast halos of invisible mass that gather ordinary matter into clusters and galaxies. Without it, gravity alone would never have been strong enough to build the structures we observe today. But Webb's discoveries suggest those halos may have formed far faster and far earlier than our simulations predict. The invisible web that holds galaxies together might have started spinning its threads long before the Big Bang's light had time to fade. Some physicists believe dark matter itself might not be constant, that its properties could evolve, interacting differently during the universe's earliest moments. If true, it could explain why Webb sees galaxies already in place, because the gravitational seeds that formed them were sown in an era we've never observed before. Other researchers take an even more radical view, that the laws of physics themselves might have shifted during the first instance of time, constants we treat as eternal, the strength of gravity, the speed of light, even the behavior of fundamental forces, may not have always been fixed. Tiny variations, even a fraction of a percent, could change how quickly stars ignite, how fast matter collapses, how galaxies assemble. If Webb's data hints that those constants were once different, it means our universe could be part of a larger pattern, where each cosmic cycle rewrites the rules before beginning again. And maybe that's why the earliest galaxies look so mature. They were born under different conditions, a different gravity, a different balance of energy and mass, perhaps even a different kind of time. The more we learn, the less the universe resembles the simple, predictable system we once imagined. It behaves more like a living structure, dynamic, evolving, changing its own laws as it expands. For the first time, cosmologists are starting to consider that maybe the universe doesn't just exist within physics. Maybe physics exists within the universe. It's not the law that rules the cosmos. It's the language the cosmos writes for itself, line by line, as it unfolds. If that's true, then Webb isn't just showing us galaxies. It's showing us the universe learning how to exist. As Webb continues to peel back the layers of the cosmos, it's exposing a deeper fracture in the foundation of modern cosmology, a problem that has been quietly growing for years. Scientists call it the Hubble tension. For decades, astronomers have tried to measure the rate at which the universe expands, the so-called Hubble constant. There are two main ways to do it. One measures the ancient light from the early universe, the cosmic microwave background, the faint afterglow of the Big Bang. The other measures the light from nearby stars and galaxies, observing how quickly they're moving away from us today. Both methods are precise, both are reliable, and yet they don't agree. The universe's expansion rate calculated from the early light is slower, while the expansion rate measured from the nearby universe is faster. The difference between them might sound small, only a few percent, but in cosmology it's catastrophic, because if both methods are correct, then something fundamental is missing from our understanding of the universe. When Webb's data arrived, many hoped it would settle the debate. Instead, it made it worse. The galaxies Webb observed, the ones that appear impossibly old, also seem to be moving in ways that amplify the tension. It's as if the space around us is expanding faster than it should, while the deeper universe lags behind. Some physicists think this is just an illusion caused by where we happen to be, that we might live inside a massive underdense region of space, a cosmic bubble where galaxies are slightly farther apart than average. Others suspect that dark energy, the mysterious force driving expansion, might be changing over time, growing stronger as the universe ages. But there's another possibility, one far more unsettling, that our measurements aren't just distorted by space, they're distorted by time itself. If time doesn't flow evenly across the universe, if it can stretch and bend the same way space does, then our perception of expansion might depend on where and when we're observing from. In other words, what looks like a faster expansion could simply be the result of time moving differently here than elsewhere. That idea sounds impossible. And yet, every time Webb looks deeper, the evidence grows harder to ignore. Maybe the cosmos isn't governed by a single universal rhythm. Maybe time itself is local, an emergent property that behaves differently depending on how the universe evolved in each region. If that's true, then we might be living in a patch of the cosmos where time flows slightly faster, and the rest of the universe, beyond our cosmic horizon, beats to a slower, older pulse. The deeper we look, the more it feels as if the universe is trying to tell us. The problem isn't how fast everything is expanding. The problem is that we still don't understand what expanding even means. To understand why the universe behaves this way, we have to confront the most mysterious force in existence: dark energy. It makes up nearly 70% of everything in the cosmos, yet we have no idea what it really is. We only know what it does. It pushes. It stretches the fabric of space itself, accelerating the expansion of the universe, driving galaxies away from each other faster and faster with every passing moment. In the late 1990s, astronomers discovered this acceleration by studying distant supernovae, exploding stars that serve as cosmic mile markers. They expected to find that gravity was slowing the expansion over time. Instead, they found the opposite. The universe was speeding up. Something unseen was working against gravity, inflating reality itself. That discovery forced cosmologists to rewrite the laws of the cosmos, to add a new term to Einstein's equations: the cosmological constant, a kind of built-in pressure in the fabric of space-time. We gave it a name: dark energy. But a name is not an explanation. It's a placeholder for our ignorance. Now, James Webb's discoveries are pressing on that ignorance harder than ever, because the galaxies it sees at the edge of time appear to be influenced by dark energy long before it was supposed to matter. In the standard model, dark energy becomes dominant only in the later universe, billions of years after the Big Bang. But the galaxies Webb observes, bright and well-formed only a few 100 million years after, suggest that expansion was already accelerating. That means dark energy might not be constant at all. It might be evolving. If dark energy is growing stronger with time, that could explain why nearby galaxies seem to be receding faster than distant ones, the very cause of the Hubble tension. It could also mean that the universe we live in now is fundamentally different from the one that existed at its birth. The rules have shifted. The energy driving expansion might not have been the same across all of cosmic history. And if that's true, then dark energy isn't just a background force. It's an active participant, a dynamic, changing field that shapes how the universe grows, breathes, and possibly dies. Some physicists even believe dark energy could be the key to the entire cycle, the spark that ends one universe and ignites the next. As a universe expands and empties, dark energy dominates until space itself tears apart in a vast, cold silence. But that silence could trigger a rebound, a new Big Bang, born from the decay of the old. In that sense, dark energy might not simply be the force that pushes everything apart. It might be the heartbeat of eternity, the pulse that starts and ends each cosmic generation. And now, Webb may be seeing the residue of that heartbeat. Faint signatures in the earliest light, whispering that our universe is only one verse in a much larger song. If dark energy is not constant, if it changes, breathes, evolves, then maybe the universe itself isn't a one-time event. Maybe it's part of a cycle. For over a century, we've treated the Big Bang as the absolute beginning, the birth of everything from nothing. But Webb's discoveries hint that this might not be true, because some of the galaxies it sees appear to have formed from structures that existed before the Big Bang's light even reached them. Their shape, their maturity, the chemical fingerprints in their stars, all suggest that something came before. This idea isn't new. Philosophers and physicists have whispered about it for decades. A cosmos without a beginning, a universe that expands, empties, collapses, and is reborn, over and over again. It's called the cyclic universe, an eternal loop of creation and destruction, where every Big Bang is both an ending and a beginning. In this model, the universe grows under the influence of dark energy until it becomes so stretched that structure itself breaks apart. Then, perhaps through quantum processes or the decay of space-time, the energy that fills the void collapses inward, igniting a new explosion, a new universe expanding from the ashes of the old. To us, that process would look like the ultimate beginning, but from the larger perspective, it's just another heartbeat in an infinite sequence. Some cosmologists, like Roger Penrose, have even suggested that traces of previous universes could still be visible in our own. Faint patterns in the cosmic microwave background, subtle rings of temperature anomalies, perhaps the ghosts of long-dead black holes from a universe that came before. And now, with Webb's unprecedented precision, we might be seeing the first hints of that continuity. Structures too old, too organized, too familiar for a cosmos that's supposed to be young. It's as if the universe remembers. Not in the way we remember, with thoughts and images, but through structure, through inherited patterns woven into its very geometry. Every galaxy, every atom, every vibration of light could be a fragment of a previous creation, echoing forward into the next. If that's true, then time itself isn't a straight line. It's a loop, a vast circle where every end folds into a new beginning. And the Big Bang wasn't the start of everything. It was just the latest verse in an infinite cosmic poem. Webb may be the first instrument powerful enough to glimpse the rhymes between those verses, the subtle similarities between what was and what is. And if it continues to find evidence of mature galaxies in the dawn of time, we may soon have to accept that the universe has no birth certificate. It's been alive forever. If the universe truly breathes in cycles, expanding, collapsing, and beginning again, then we have to ask the most unsettling question of all. What happens to us in that cycle? If galaxies, stars, and matter are reborn, could life be too? Could consciousness itself be part of the universe's rhythm, emerging, fading, and returning with each new creation? In every known cycle of nature, life finds a way to return. Stars die, scattering elements across space. Those elements form new stars, new planets, and eventually living chemistry. Carbon and oxygen, forged in stellar furnaces billions of years ago, now flow through our veins. We are not just made of the universe, we are its memory. If the cosmos repeats itself, perhaps consciousness is not an accident that happened once, but a feature written into the structure of existence, a self-recognizing pattern that emerges wherever matter becomes complex enough to ask questions about itself. Some physicists have even proposed that information, the fundamental ingredient of thought, can never be destroyed. That means every memory, every act of perception, every moment of awareness leaves an imprint on the universe's fabric, faint but permanent. If that's true, then when the universe renews itself, those imprints don't vanish. They become the seeds of new order, shaping the next version of reality. guiding it towards self-awareness once again. It would mean consciousness is not confined to biology. It's a cosmic phenomenon, arising naturally whenever the universe learns to look at itself. In this view, life isn't the exception to the laws of physics. Life is physics. Organized information finding balance between chaos and order. If the universe has lived and died countless times, then life, in some form, might have existed in every cycle. Not the same life, not the same species or civilizations, but the same principle, awareness returning like a spark in each new world. Perhaps this is why the universe seems fine-tuned for life. Not because it was designed for us, but because we are part of the pattern, a recurring expression of the cosmos, learning what it means to exist. And maybe that's why, when we point telescopes like Webb into the void, what we're really seeing is not just light from the past. We're seeing reflections of ourselves, echoes of a universe that has dreamed, died, and awakened countless times before. If the universe really does renew itself, something must carry the memory forward, a link between what was and what comes next. And in the darkness, we may have already found the answer. Black holes. They are the strangest objects ever discovered. Points of infinite density where the known laws of physics collapse. To most of history, we've seen them as endings, the death of stars, the swallowing of matter, the edge beyond which nothing returns. But what if black holes are not tombs, but gateways? Every galaxy has one at its heart, including ours. They feed, they grow, and yet they don't disappear. Even when they stop consuming, they continue to radiate. Faint ripples of quantum energy known as Hawking radiation. Stephen Hawking's theory showed that black holes slowly evaporate over time. But what happens to the information they contain? The record of everything that ever fell inside? That question, the black hole information paradox, has haunted physics for decades. If information is truly lost inside a black hole, the laws of quantum mechanics break. But if it somehow survives, then black holes might be storing the blueprint of the universe itself. Some theories suggest that when a black hole reaches its final moment, when it can no longer hold its mass and evaporates completely, it doesn't simply vanish, it explodes, and that explosion could be indistinguishable from a Big Bang. Imagine every black hole as a seed, a compressed universe waiting to unfold. Inside, space and time might reverse, expanding outward into a new cosmos, while from our perspective, the event looks like the quiet end of an old one. In this picture, each black hole could give birth to its own universe, and every universe could be born inside a black hole from another. An infinite nesting of realities, each one carrying the encoded memories of its parent. If that's true, then our own universe might have begun inside a black hole that existed in another. The singularity we call the Big Bang could have been the final breath of a dying cosmos, its information compressed, transformed, and reborn as ours. Webb's observations may be our first glimpse of this deeper architecture, the faint traces of order carried through cycles of creation. When it looks at the earliest galaxies, it may be seeing the fingerprints of a previous universe imprinted into ours. Patterns too subtle to erase, too ancient to forget. And if black holes really are the universe's memory cores, then everything that falls into them, every atom, every photon, every story, is not lost. It's written into the next chapter of existence. Maybe that's what eternity really means. Not endless time, but endless transformation. A universe that never dies because it never stops becoming. For more than a century, we've treated the Big Bang as the ultimate beginning. A single instant when everything, space, time, matter, energy, burst from nothing. The starting point of reality itself. But the deeper we look, the less the Big Bang feels like a beginning, and more like a transition. Webb is forcing us to see the Big Bang not as the birth of the universe, but as a moment of transformation, the boundary where one reality folded into another. When physicists try to describe what happened before the Big Bang, the equations stop working. Space and time both reach zero. Cause and effect disappear. It's as if the universe itself refuses to let us peer behind the curtain. But new models suggest there may be no before to look for, because the Big Bang didn't happen in time. It created time. In that sense, the Big Bang wasn't an explosion within space. It was the creation of space itself. Not something expanding into emptiness, but emptiness expanding into something. And maybe that expansion began inside the event horizon of a black hole, the singularity of one universe blooming into the birth of another. If so, then every Big Bang might be a bridge, a recycling of energy, a conversion of collapse into creation. The laws of physics don't end at the singularity, they transform. Gravity becomes expansion, collapse becomes birth, death becomes beginning. Webb's images, filled with galaxies that shouldn't yet exist, hint that the early universe inherited structure from something older. It wasn't pure chaos. It was organized, already patterned, as if the Big Bang wasn't random at all, but guided by the encoded geometry of a previous cosmos. That could explain why the universe seems fine-tuned, why physical constants fall within such narrow ranges that allow matter, stars, and life to exist. It may not be coincidence. It may be inheritance. Each cycle of the cosmos could refine itself, adjusting physical laws ever so slightly, selecting for balance, for harmony, for complexity, until life itself becomes inevitable. If that's true, then we are the product of countless cosmic generations, each universe passing down the memory of existence to the next. The Big Bang, then, was not creation from nothing. It was continuity. A whisper from an older world, echoing through the fabric of this one. And that whisper may still be audible, faint, buried in the cosmic microwave background, hidden in the pattern of galaxies, and perhaps even within us. Because if the universe remembers, then so do we. Every new discovery from Webb doesn't just add a piece to the puzzle. It changes the shape of the puzzle itself. And that's what's happening right now in cosmology. A quiet revolution. A breaking apart of the model we've trusted for nearly a century. For decades, the Lambda CDM model has been our map of the universe. It describes a cosmos born from a hot, dense beginning, expanding under the influence of dark energy. That's the lambda, and structured by cold dark matter. That's the CDM. It fits our observations beautifully, or it used to. But Webb's vision is sharper, deeper, and older than anything before it. And what it's seeing doesn't quite fit. The galaxies it's revealing in the early universe are too massive, too evolved, too organized. Their stars are rich in heavy elements that shouldn't exist yet. Their shapes, disks, spirals, even clusters, appear billions of years too soon. And so the cosmological model begins to strain. Some scientists argue we're just missing data, that what looks ancient might be tricked by dust, or lensing, or misinterpretation. Others think Webb's discoveries are the first hints of a deeper layer of reality, one that the standard model can't reach. It's a divide that runs through every observatory, every conference, every late-night physics discussion on the planet. One side says, we just need more data. The other whispers, we need a new theory of everything. This is how science evolves, through tension, through the uncomfortable realization that our best explanations no longer explain. And it's happening again, just as it did with Einstein a century ago. We once thought time was absolute. Einstein shattered that illusion. Now, we think the universe began with a single explosion. But Webb may be about to shatter that too. A handful of researchers are already building new frameworks, ideas that stretch from quantum gravity to the holographic principle. They imagine the universe as information written on the surface of higher dimensions, or as a simulation of geometry unfolding in time. Others see it as a self-organizing network, a cosmic neural web, where galaxies are the neurons and gravity the signal that binds them. Every one of these theories tries to answer the same question. Why does the universe look older than it should? And the answer might not be out there in the galaxies. It might be here, in the assumptions we make about what time and reality even mean. For the first time in living memory, cosmology is back in the realm of the unknown. Not the quiet confidence of a field with all its constants neatly labelled, but the raw, exhilarating uncertainty of discovery. We stand where ancient astronomers once stood, looking at the sky and realizing that everything we thought we knew might be wrong. And that's the most exciting place science can be. As the cracks widen in our model of the cosmos, one idea keeps resurfacing, a possibility so vast that it feels almost mythic, that our universe might not be alone. The multiverse. For years, it was dismissed as fantasy, philosophy dressed in physics. But now, as Webb's images reveal galaxies forming too soon and matter behaving too strangely, the multiverse is starting to look less like speculation and more like the simplest explanation left. In some versions of the theory, every universe begins as a quantum fluctuation, a bubble of energy in a larger cosmic field. Most bubbles collapse in an instant, but a few expand, inflate, and become universes like ours. Inside each one, space, time, and physics take on unique forms, different constants, different dimensions, different laws. We live in one bubble of reality, but there could be an infinity of others, each floating in the endless foam of creation. This is known as eternal inflation, a process where new universes continuously bud off from older ones. And if that's true, then our Big Bang wasn't the beginning. It was simply our local inflation, the spark that lit this particular bubble. Some cosmologists go even further. They suggest black holes might be the engines that create those new bubbles, that every collapse in one universe births an expansion in another. If that's true, the multiverse isn't just parallel, it's genealogical. Universes giving birth to universes, each inheriting traits from their parent. A cosmic family tree, branching infinitely into eternity. That could explain the fine-tuning we see in our universe. Why the laws of physics seem so perfectly balanced for the existence of life. Because universes that can't form structure collapse and vanish, while those that can survive, and eventually observe themselves. In that sense, the multiverse is not chaos. It's evolution on a cosmic scale. If this is true, then the James Webb Space Telescope isn't just showing us distant galaxies. It's showing us our context, the realization that everything we know, every atom and star and thought, is part of something infinitely larger. And in that larger structure, maybe consciousness isn't confined to one universe. Maybe it arises again and again, different each time, yet bound by the same fundamental drive to look up, to wonder, and to ask where it all began. Because perhaps the question isn't, how did the universe start? But, why does the universe keep starting? And maybe Webb, unknowingly, has just taken the first photograph of eternity. Not the end of discovery, but the beginning of everything we have yet to imagine. If the universe isn't alone, if countless realities are being born and reborn, then perhaps time itself isn't what we think it is. We treat time as a river, flowing in one direction, past to future. A steady, irreversible current that carries everything with it. But physics has never actually proved that time flows. Our equations work perfectly well backward. To the laws of nature, past and future are interchangeable. It's only consciousness, only us, that seems to experience a direction. Einstein called time a dimension, not a current. In his universe, time doesn't move. It exists. Every moment, from the birth of the cosmos to its last flicker, is already written into the fabric of space-time. To him, the universe is a four-dimensional sculpture, and what we call the passage of time is simply our awareness moving along that sculpture's surface. But if Webb is right, if galaxies at the edge of time already look ancient, then maybe the sculpture is larger, more complex, woven not as a straight timeline but as a spiral, looping back on itself in ways we can't yet perceive. Some physicists now believe time could be emergent, not a fundamental property of the universe, but something that arises from entanglement, from the collective behavior of information itself. In this view, time isn't the stage where reality unfolds. It's the story that matter and energy tell as they interact. That means time could run at different speeds in different regions of the cosmos. It could stretch and contract depending on gravity, density, or even the quantum state of space. In the deepest voids, where matter is thin and gravity weak, time might accelerate. In the dense hearts of galaxies, it might slow. To each observer, the universe would appear consistent, but across the grand expanse, the rhythm of reality would beat to 1,000 different tempos. And if there are other universes, born from black holes or cosmic cycles, each one might carry its own timeline, its own definition of before and after. From the outside, the multiverse might not be a sequence of events at all, but a vast, timeless structure, a cosmic library where every possible moment already exists, and consciousness merely turns the pages. When we say the universe is expanding, maybe what we really mean is that time itself is deepening, branching into new forms, creating new perspectives from which reality can experience itself. And that's the ultimate revelation Webb may be leading us toward. That time is not a line we travel, but a landscape we inhabit. Every birth, every death, every discovery, all happening at once, woven together in a single, eternal present. If time is not linear, if it's a landscape, not a line, then what we call reality might not be something that happens. It might be something that simply is. Every atom, every galaxy, every thought that's ever existed could still exist right now. Not as memories, not as ghosts, but as points on a timeless map of being. From our limited perspective, we move through that map one frame at a time, and we call that motion life. But in truth, every moment, every version of the universe may already be there, stacked together like pages in a book too vast for us to read at once. To us, cause and effect feel like laws. But to the universe, they may just be a pattern, a rhythm that arises within the greater harmony of timeless existence. Quantum physics has already given us hints of this. In the quantum realm, particles can exist in multiple states at once. Their behavior depends not only on the past, but on the act of observation, on choices that haven't yet been made. Experiments have shown that actions in the present can affect outcomes in what we would call the past. Reality seems to rewrite itself to stay consistent with what is observed. It's as if the universe doesn't exist as a fixed sequence of events, but as an evolving whole, a self-correcting network of probabilities constantly rearranging itself to make sense of its own story. This is what physicists call the block universe, and what philosophers have long suspected, that existence is not a moment in motion, but a structure in totality. We are not moving through time, we are woven into it. And maybe consciousness is how the universe experiences that structure from the inside. Each observer, human, alien, or cosmic, is a unique perspective, a lens through which the universe sees itself. What we call reality is simply the intersection of those perspectives, a shared illusion that lets existence feel continuity. Webb's images, then, aren't just snapshots of the distant past. They're glimpses of other coordinates in the same eternal fabric. Light that left its source billions of years ago is still arriving now, because now and then are not truly separate. They coexist, folded together in the geometry of space-time. That means, in some sense, nothing is ever truly gone. Every birth still burns. Every death still echoes. Every question, once asked, still vibrates through the cosmos. And every act of seeing brings part of that infinite structure into focus. Maybe that's why, when we look at Webb's deep field images, those endless dots of light stretching back 13 billion years, we feel something more than scientific curiosity. We feel recognition. Because on some level, we are looking at another version of ourselves, not separate from us, but simultaneous with us, woven into the same cosmic moment. If the universe is timeless, if every moment, every version of reality coexists, then what are we inside all of this? Just temporary patterns of matter? Or something more, something the universe uses to look back at itself? For centuries, we've imagined ourselves as small, a fragile species on a tiny world, orbiting a modest star, in an ordinary galaxy, lost among trillions. But maybe smallness was never the right word. Maybe we are something much rarer, localized awareness, the part of the cosmos that has learned to ask questions about its own nature. When you think, when you wonder, when you stare into the sky and feel that impossible pull toward infinity, that is the universe experiencing itself through you. Your consciousness is not separate from the stars. It is their echo, the continuation of their light in a different form. The carbon in your body was forged in ancient suns. The iron in your blood was born in supernovae. The calcium in your bones came from the death throes of stars that lived before Earth even existed. Every breath you take, every thought you think, is a collaboration between the cosmos and consciousness, between physics and awareness. And if the universe has cycled through endless births and deaths, then maybe consciousness does too. Not the individual mind, not memory or personality, but the capacity for awareness itself. It could be as fundamental as space or time, emerging wherever complexity allows the universe to know itself again. That means, even across cycles of creation, the essence of awareness might never disappear, but it might only transform, reappearing in new forms, in new beings, on new worlds. Maybe that's the real legacy of the universe, not stars or galaxies or black holes, but awareness itself. The universe might not be a machine. It might be a mind, an infinite field of experience, learning, evolving, and remembering through every cycle. And when we look through James Webb's mirrors into the depths of space, we are not looking into the past. We are looking into our own reflection. Ancient light returning home to itself. The photons that strike Webb's sensors have traveled for billions of years, crossing time, void, and darkness, just to end their journey in the same consciousness that first wondered where they came from. Light left the stars, and in us, it found eyes to see itself again. Perhaps that is the meaning of existence. Not survival, not progress, but recognition. To know that you are not apart from the cosmos, but of it. A brief and brilliant instance of the universe becoming aware that it is infinite. What if the universe isn't expanding into emptiness, but into awareness? Every discovery we make, every equation we write, every image captured by the James Webb Space Telescope isn't just knowledge added to the universe. It's the universe remembering itself. When a new galaxy is seen for the first time, that galaxy doesn't just appear to us, we appear to it. For the first time in billions of years, its light has found eyes that can understand it. In that instant, two parts of the cosmos become one again. Maybe that's the true expansion of the universe, not measured in megaparsecs per second, but in moments of realization. Every act of seeing is a reunion. Every question we ask, a spark of awakening. James Webb was built to see the earliest galaxies, but in doing so, it may have shown us something even older, a truth buried in the fabric of everything, that the universe is not a cold, indifferent expanse, but a living continuum of memory and perception. The deeper we look, the older the light we find, until one day perhaps we will see past the Big Bang itself, into whatever existed before time began. And when we do, we may realize that we were never looking back at all. We were looking within. Because the boundary between the observer and the observed, between the scientist and the cosmos, was always an illusion. You are not a speck in the infinite. You are the infinite looking at itself through a human frame. Every telescope, every experiment, every question is the same ancient curiosity echoing through different forms. The universe has been trying to understand itself since the first light broke through the dark. And right now, through us, it finally can. So maybe the Big Bang wasn't the beginning. Maybe it was the first breath of awareness, and everything since, every star, every life, every act of wonder has been part of that awakening. If that's true, then we are not just observers of the cosmos, we are participants in its unfolding consciousness, each of us a flicker in the grand illumination of existence. And as we continue to look deeper, to ask harder questions, to reach further than ever before, remember this: we are not small, we are not lost, we are how the universe learns to see. Thank you for coming on this journey, for traveling across time, thought, and the edge of everything we know. If you've made it this far, you are part of the rare few who dare to look deeper, who feel that quiet pull toward the unknown and choose to follow it anyway. The universe is vast beyond measure, but curiosity, your curiosity, is what gives it meaning. So if this exploration made you see the cosmos differently, if it reminded you that we are not just in the universe, but of it, then don't let the journey end here. Hit that like button, subscribe for more deep dives into the mysteries of existence, and share this with someone who still looks up at the night sky and wonders what's really out there. Together, we'll keep exploring, not just the stars above, but the vast universe within. Until next time, keep watching the skies. And remember, you are how the universe learns to see.